I have a little practical note here, just because practical chemistry is interesting. So for aqueous reactions, and notice, or you could call that aqueous, this is what you do in Gen Chem 1, because people aren't going to give you guys crazy chemicals to work with. But most of them, they're going to be aqueous, but they don't have to be. Just, you're going to see mostly chemical reactions that are aqueous, but you can have gas as a reactant. And to do that, what they do is they bubble it through water, like in a fish aquarium. You're adding oxygen to the water. You're adding air, whatever you're adding to the water, you're bubbling it through the water, and some of it gets absorbed into the water. Or if you make a gas, so this is just practically, if you make a gas in a reaction that's in water, so here's our reaction, it's in water. If one of the products is the gas, some of the gas will dissolve in the liquid, and then after that, it's going to just keep rising up because it has less density. And what people will do is they'll have like a container on top that's empty, and they're like collecting the glass in that container, and it has a way to seal it. It's got some kind of a sealing spot to seal it. So also some reactions, you don't even have to all be water. You could have an oil layer, because you know how if you take an oil layer and a water layer and you shake it really, 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 really hard, it like emulsifies, and they are passing through each other. Well, if you do that with acidic or basic water, you can have a reaction happen in there. And then sometimes when you do a reaction, if you do it in water, sometimes, so here's your water, and say you do a reaction in the water layer, sometimes the product will be an oil that's on top, and sometimes it'll have a color, and sometimes it won't. You can also make solids, and they just sit at the bottom. So you can have your container and your liquid, and then you end up with just like a chunk of something at the bottom. Sometimes it's finely dispersed all over. Sometimes it's kind of will get stuck all over all the sides, but it's definitely solid, little bits of solid. So those can be produced, and they sit at the bottom, and they can be filtered. And you guys have already done a lab in this where you have like a coffee filter, like coffee. If you pour something through a filter, then the solid will sit on top of the filter, and then the liquid will go on through. So you can also do solids as reactants. You can have two reactants, but it's kind of a tricky situation to do that. If you think of, there's not a lot of cases of it in real life, but if you take two solids and you mix and you heat them up, or usually you have to like have something hit them really hard, but a reaction will happen, but they're hard to manage. So that's why most of the time we dissolve reactions in liquids. They're easier to manage, and they're just more friendly, I guess is the best way to put it. But just a little summary. Just remember, you can have all kinds of phases in reactions. So I've got some info on this page. If you're reading through on OpenStax, you're not going to find this. I don't know why it's not here, but here's a reminder of a few things. First of all, there are 7 diatomic elements, and we talked about those. Those are the ones that kind of make it 7 on the periodic chart. Plus over here we have our hydrogen. So we have N2, O2, F2, Cl2, Br2, and I2. And then hydrogen, H2. That's in the periodic chart. If you find it, it'll look like that. And so there are 7 of them. And their names are, we just call them hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, make sure my screen's and iodine. That matters because a lot of times we'll use words to describe our equations. So here we go on some of our exciting words. We can write an equation completely with words. So let's convert these words into an unbalanced reaction, and we'll deal with that later. These contain things that are diatomic. So diatomic is when they exist as a pair. Everything else on the periodic chart doesn't. So like up here, these are the ones that are the pairs. The other stuff isn't. You don't have to know any of the special weird cases. So hydrogen gas, that's how we phrase it, hydrogen gas. So we would write H2 reacts as a gas, reacts with oxygen gas, O2, because we use the word oxygen. The G is for gas. Then the word to form, there's our arrow, and then we have water. Now, I didn't say whether it was a liquid or a gas phase. I'm going to add as a gas. It would be something like that. And then you would know. There you go. When it reacts with oxygen gas, butane gas, so did you hear how that was phrased? So basically what they're saying is that butane is reacting with oxygen. So C4H10, and it says it's a gas, plus oxygen gas, will produce carbon dioxide gas plus water. And I'm going to write water as a gas also. I'm going to put in here as a gas. So now you take a minute and you do the third one. So at least you've had a moment to think it through. So aluminum metal, what phase is some aluminum foil? Because that's aluminum metal. What phase is that? That's a solid. So Al as a solid. And it says it's placed on and a reaction occurs. So that means plus the bromine. And it's a liquid. It says it occurs. And it says what it makes is aluminum bromide. Now you might have to think, if you can't remember this, this was from chapter 4. That's plus 3 and he's minus 1. So I'm going to need 3 bromines. And it says a salt. So think about all the salts you know. Are they liquids? Are they solids? Yeah, they're solids. So this is a third way that you can see things about phases.